everybody. I hope you're enjoying your day one of reInvent. Thanks very much for making the trek all the way out to Mandalay Bay. So I'm Jody Gibney. I lead product management for EBS, and I'm presenting with Heather.
Hey guys, my name is Heather Horbaczek. I'm a product manager for EBS.
Cool. Well, thanks, Heather. Today we're going to be walking you guys through what's new with EBS, some of the functionality that we've introduced over the last year, and also covering some best practices, tips and tricks. It's a 200-level session, so the expectation is that most of you are familiar generally with what EBS is. I'll cover a couple refresher slides, but certainly in Heather's portion, we're going to dive into way more detail. So, cool. Here we go. Oops. How do I make this go? There we go. Okay, so as a refresher, EBS at its most basic is network attached persistent storage, basically block storage for EC2 instances. The storage is network connected, so it's disaggregated from your EC2 instance. You know, you can start your instance, your EBS volume will still be there, and it has separate lifecycle. EBS also provides the ability to create snapshots, and it has a bunch of other data services functionality. One thing that's important to remember is that EBS is not just a provision disk behind the scenes. So EBS is a vast distributed storage system, and that is maintained and operated by our team of EBS engineers. And it is through that system that we're able to offer different volume types that meet different performance expectations, durability expectations, et cetera. Right. So the most fundamental value prop of EBS is performance, right? It is straightforward, high performance block storage that you can use at virtually any scale. And we have different volume types that offer different performance levels. Our performance, though, has evolved quite a bit over time. Come on, slide. So this is actually, I'm celebrating my 10th year with AWS. I started my career and be a little stick figure in 2014 when I was really excited about getting some dedicated EBS bandwidth. When EBS launched in 2008, you could drive only 100 IOPS on bandwidth that was shared with network traffic. Flash forward to today, and things have changed quite a bit. You can now drive up to 256,000 IOPS through a single volume on dedicated EBS bandwidth, or up to 420,000 IOPS to a single EC2 instance. So we're constantly pushing the envelope on performance. These numbers get out of date really, really fast, so keep an eye on this. It's something that we continually improve. So jumping back, not only does EBS offer performance as our core feature, but we offer a highly reliable and durable storage service with up to 5 nines of durability provided by our IO2 block express volumes. In addition, we continuously focus on security. So I'm not going to go into all of the security features that EBS has, but I will mention one. You can encrypt all of your new EBS volumes in a region by setting one setting. So that's something that we try to make very easy for you to enjoy high performance, secure storage. So before diving into our new features, I wanted to talk a little bit about how we think about resiliency. The reason that this is very relevant to our 2024 roadmap in this talk is that a lot of our focus in 2024 was on providing customers with features that would support designing resilient architectures. So what do I mean by resiliency? I mean essentially making sure that your application is available when you need it to be. There are 3 main steps that you go through to think through resiliency. So the first bucket is to understand potential risks and disruptions. So these are, dependencies that your service may have that impact your application's availability. They're disruptions like volume loss or a network disconnect that you have to think through. So depending on the specific nature and sensitivity of your application, you need to figure out what are the kind of disruptions that I'm likely to experience. So secondly, you want to minimize the scope of impact and figure out, so what is the blast radius of the various disruptions that my service can encounter, my application can encounter. So in this step, you're thinking through, okay, if my application is unresponsive, what else is impacted in my business? Is this a non-critical service that really, could go down, it's not a big deal? Or is this something that's highly critical, maybe logging customer transactions or something like that? So lastly, you have to think through recovery. So as you've identified your risks, you've looked at all of your dependencies, and you figure out how quickly can I recover from one of these disruptions, and ideally automate that recovery. So Heather's gonna be talking about this in a lot more detail, but I wanted to kind of provide that upfront framework. So jumping into the first bucket, understanding risks and potential disruptions. So a key piece here is evaluating the dependencies that your application has that affect availability, because an interruption in any service that you have a hard dependency on is going to cause an interruption in your service. So when you're designing for availability, the first thing you need to ask yourself is, what is the impact to my customers or my core business if this application experiences a disruption or an outage? So if the answer is that, wait, my core business is going to be critically impacted, then odds are you've got a tier 1 mission critical system, and you need to take that into consideration as you're architecting for availability and resilience. So EBS has a bunch of different volume types for different application needs. I'm going to quickly kind of summarize. So GP3 is our latest general purpose SSD volume type. It provides sufficient IOPS and throughput performance for most workloads. So if you need to remember one thing about which volume do I choose, if you don't know, just start with GP3. It's a good choice for most everything. IO2 block express volumes, on the other hand, are specifically designed for your most critical, high-performance applications that are IO intensive and require the lowest latencies consistently. ST1 volumes, for example, are great for big data and analytics workloads if you need high throughput, but maybe don't have the same latency and IOPS requirements. And then there's ST1 volumes, which are basically for kind of pre-archival use cases, where you need to have your data online, but it's infrequently accessed, and therefore they are super cheap. So one thing that I'll talk about at various points in the presentation is storage flexibility using elastic volumes. So our elastic volumes feature allows you to dynamically change volume type, increase size, change IOPS or throughput performance levels of your EBS volume without application downtime or impact. So now that we have an understanding of the basic capabilities of different volume types, we need to understand your application's requirements. So the first questions, I think, to address are, what are your performance needs, right? What does your application need in terms of IOPS and throughput performance, and also in terms of latency? There are other questions like database replication, for example. Are you going to be using any built-in features of your database that are replicating data to a different availability zone or region? That's another thing to consider. And then similarly, on the performance front, do you need the highest and most consistent performance of IO2 block express, or is your application going to be generally satisfied by GP3's performance, which has a great price performance profile? Lastly, obviously, and this is not an exhaustive list, there's just a handful of storage-related considerations, what EC2 instance type do you need? Are you happy with one that has bursting performance? Do you need dedicated bandwidth to EBS? And then you also got to check your instance to EBS maximum IOPS and throughputs, as well as what your individual volume or volumes can do. So again, if you don't know, use GP3. It comes with a baseline of 3,000 IOPS per volume and 125 megabytes a second of throughput with a maximum of 16,000 or 1,000 megabytes a second. You can provision additional throughput or IOPS performance separately if you need it, but this is what it comes with as a starting baseline. So IO2 block express volumes were built very specifically for the highest IO-intensive performance requirements and to provide consistent sub-millisecond latency performance. So things like IO-intensive applications, databases, are very, very frequently at the core of critical business transactions. So IO2 block express was designed with those in mind. When we were designing IO2, we actually designed a new networking protocol called SRD, which stands for Scalable Reliable Datagram. Not that you'll probably ever use that, but that's what it is. That guarantees the lowest latency and most consistent networking within our computing environment. So all IO2 block express volumes run on the SRD protocol. And this is why, when you're looking for that highest tier performance, when you need really consistent sub-millisecond latencies, IO2 block express is the volume that we specifically designed for those purposes. So last year at reInvent, we announced that IO2 block express volumes are now available on all EC2 instances built on the Nitro platform, the Nitro system. So with a single IO2 block express volume, you can drive up to 256,000 IOPS or up to 420,000 IOPS per instance, or a storage capacity of 64 terabytes, which is 4 times the storage capacity and max IOPS and throughput performance of our previous fanciest volume, IO1. You'll automatically benefit from the latest improvements in our EBS server architecture and 99.999% durability. That's 5 nines of durability, which is 100 times greater than IO1. So to talk a little more about latency and latency consistency, when I say that IO2 block express is 10x reduction in outlier latencies, this is what it actually looks like in a graphical form. So you can see that as you get into the outer percentiles, where things are happening, granted, less frequently, IO2 block express maintains a very, very consistent low latency performance when compared with GP3, for example, which is the red line up there. You can see higher outlier latencies. So that's one input into your designing for resilience. It's how does my application respond to a single outlier IO with higher latencies? And if you need that latency consistency, then IO2 block express is volume for you. If you don't, then use GP3 because it'll work great. So just to recap, you've got IO2 for IO-intensive, performance-intensive databases. You have, for things like a streaming Kafka workload, ST1 is great. And if you don't know, just use GP3. So for those of you who are running databases on RDS, in March, RDS announced that they'll be supporting IO2 block express volumes, the same price of IO1 volumes. And you can upgrade from RDS on IO1 to IO2 block express with no downtime whatsoever. So we've heard from customers like Figma, right, who have been able to take advantage of the lowest latency consistency that IO2 block express provides. They were able to make the transition from IO1 to IO2 in a week or two using the elastic volumes feature that kind of will enable that dynamic volume morphing. For those of you who are running containerized workloads, this year we announced EBS task attachments on ECS, EC2, and ECS Fargate. So for Fargate customers in particular, this was a great improvement because you no longer have to rely on the max 200 gigabytes of an ephemeral Fargate volume. Instead, you can attach a volume that resides in your account as opposed to the central Fargate account. And for example, if you need to hydrate a volume, like pre-populate a volume before you launch your container with a specific data set, you can do that via EBS snapshots. So this is a big improvement, particularly for Fargate customers. You can specify all of that in the Fargate task definition. So you can upfront specify what volume type I want, what performance specs I want to, up to the maximum EBS supports. And you can use our elastic volumes feature to modify volume performance and volume type. So with that, I will hand it over to Heather.
Thanks, Jody.
Take my water.
So I'm going to jump back to kind of how we were thinking about resiliency, right? So first off, I want to jump into that second bucket of minimizing scope of impact. So it's super important to minimize the scope of impact to reduce that impact that you have to your end customers when you do see an issue. So in EBS, we work relentlessly to prevent failure and performance degradations. And I would say that we've gotten really good at having a highly available and performant service. But it's still going to be really important for you to minimize that scope of impact in those rare cases that you do see a failure in your infrastructure. We want to make sure that, of course, you're minimizing that impact to your end customers. So when I say failures, it's really important to note that failures aren't binary. It's not did it fail or did it not fail, right? There's going to be the spectrum of impact. And so how we think about failures is really, what is the functionality that was impacted? And was it completely unavailable? Or did it have a partial impact? And then how many customers were impacted? Because you want to reduce that. Or how many workloads? Or how many locations? And so really, one of the important ways to minimize the scope of impact, first of all, is to build using multiple zones, availability zones. And so why is that, right? One of the bedrock principles of EBS is availability zone independence. And by that, what it means is that we avoid single points of failure across multiple availability zones. And so each of the availability zones will have separate power, backup power, networking, control plane. And so by having this, this allows customers to increase the availability of their workload when they architect using those multiple zones. And so that's something that we're going to recommend right off the bat. But another way to minimize the scope of impact is to make sure you're monitoring volumes. You want to make sure that you can take action as quickly as possible when you do see a failure. I've heard from a lot of customers that a lot of the times, the longest part of it is root causing what's going on when they see application performance issues. And so when we think about monitoring, there's actually 3 different levels that you should monitor at. The most granular is going to be monitoring the individual volume level. EBS, by default, gives 1-minute metrics on all of your attached volumes. And with that, you can monitor things such as your I/O performance or your latency. The middle tier is going to be monitoring your volume performance at the instance level. And so monitoring at this level is going to give you, it's the instance and the volumes that are attached with it. And at that level, you can monitor things like the performance that you're driving on your instance, so your throughput or your IOPS. So EC2 by default gives 5-minute granularity on their metrics, and you can also enable 1-minute metrics using detailed metrics. And the highest altitude of your metrics is going to be monitoring at the OS level. And so that's going to be using the CloudWatch agent, and so it's going to come as custom CloudWatch metrics. And so with those metrics, you can actually get up to 1 second of granularity. So often, I've actually asked customers in the past, hey, are you monitoring your volumes? And I'll get, of course I am. But when I dig into it, they're not actually monitoring all the stacks. They're just monitoring at the OS level. And that's gonna be great, right? That's gonna tell you, are you seeing an impact for your end customer? But it's not gonna tell you what layer of your infrastructure that you're actually seeing that performance bottleneck. So it's important to monitor all three. And with this, to help customers with this, over the last 2 years, EBS has been investing in giving our customers better signals to help you monitor your volume. And there's 3 things that I actually recommend that you monitor. These are the best practices that I recommend. So the first, volume health. Are I/O completing on your volume, or is your volume impaired? Second, I/O latency. This is the storage latency for your volume, because you want to know if there's that application latency, what layer of your infrastructure is it at? And the third is your total operations in bytes. What performance are you driving on your volume? You know, or is your volume or instance correctly sized for your workload? And so last year, we actually started with volume health to give you better signals for your volume health. We actually launched 2 different sets of CloudWatch metrics. The first is an instance level status check. So it's a binary signal that looks at all of the volumes attached to your instance and says, hey, are all of them able to process I/O, or is any of the volumes impaired? The second is a volume level check. So it's a stalled I/O check, and what it's looking at is the I/O performance for your volume and saying, is this volume able to process this I/O? Have you submitted I/O to your volume that's just sitting in the queue? And so both of these metrics are 1-minute metrics, free of charge for all of your attached volumes. And with that, last year, we also launched the EBS Pause I/O action and fault injection simulator. This is gonna allow you to test if your volume were to become unavailable from a couple seconds to multiple hours. It's gonna be able to tell you, hey, how does your system respond to it, right? If there's a short disruption, is it able to withstand it? Or how does your system recovery work if you have those longer disruptions? This will also allow you to test your alarming if you've built some based on those 2 CloudWatch metrics. So hopefully you guys caught these ones last year, but if not, hopefully you learned something new. But let's talk about what we've been working on this year. So this year, we've actually concentrated on I/O latency. And when I say I/O latency, what we're really talking about is the time between sending a read or write operation to an EBS volume and when that operation is completed. And so, like I mentioned, it's important to know your volume level latency. So if you do have that application impact, you can pinpoint where it is. This year, to help make it easier for you to track your latency and your volumes, in late October, EBS launched a set of CloudWatch metrics to help you track that average latency. This is gonna reduce that time to root cause if you do have an application latency or a volume latency impact, right? So, and you can use standard CloudWatch functionality. So you can set alarms based on a threshold, or you can use some of the inbuilt CloudWatch functionality like anomaly detection to say, hey, am I seeing something weird on this volume? So these metrics are available like all of our other metrics. These are a 1-minute granularity on all of your attached volumes. Jumping into the third bucket, the total operations in bytes. Like I mentioned, it's important to know what you're actually driving on your volume, right? You want to make sure that your volume is correctly sized, because if it isn't, and you're hitting your volume performance limits, it could be causing higher latency than you anticipate. And so we heard feedback from customers that they were actually struggling to know, they weren't really sure when they were hitting those volume performance limits. They saw higher latency on their volumes, but they weren't sure, is it because I'm hitting my limits, or is it because there's an infrastructure issue? And so in October, we also launched this set of CloudWatch metrics that will tell you when you're consistently hitting your performance limits. And so this is gonna help you root cause. And if you see these metrics flag, it can give you a signal that, hey, you need to go resize your volume, or maybe you just need to load balance between nodes. And so also available 1-minute granularity for your attached volumes. But I know some of you guys have very latency sensitive applications, right? And we've heard that a minute may be way too long for you to actually act on. You want that nitty-gritty detail on your I/O performance. And so for that, for you guys, we recently launched EBS detailed performance statistics. So using these, you can actually see the performance on your volume as little as 1 second of granularity. So these are going to be directly available in the NVMe controller of your instance and give you real-time statistics into what's happening on your volume. And so these are going to let you let you root cause quickly if your application performance bottlenecks are at your volume level. So what does it look like? Well, in some ways, it's going to give you a lot of similar statistics as to what you get in CloudWatch, right? But obviously at a different granularity. Versus the 1 minute, you guys can do it here in whatever granularity you want, so up to 1 second. So when you use the EBS NVMe-stats in your NVMe CLI, you'll be able to see total ops, read and write ops, total bytes, time. So that's similar to CloudWatch. We've also built in when you're hitting either your volume level limits or your instance level limits. So what it's going to show you is the number of microseconds in which the application hit any of those limits. And so that's going to let you know if you're consistently hitting them, you should probably resize some of theirs. And then thirdly, and I think this one's really cool, you can now see the I/O latency histograms for your volume. This is going to allow you to see the performance of every single I/O that you're driving on your volume and kind of what that looks like. And so I know it looks like a lot of numbers, but you can do some pretty cool things with it. So if you pull those histograms into some of your observability platforms, let's say Grafana, which this one is, you can see some really cool trends in your performance. So here, you can actually see the P50, the P90, and the P99 I/O latency for the volumes during that period. And so if you have a latency-sensitive application, and I hope you're using IO2 for those, like Jody was mentioning, but you can actually see what that outlier latency looks like. And so for those performance-sensitive applications, if you're seeing consistently higher outlier latency than what your application can withstand, you can take recovery actions, so whether that's load balancing or changing to a different node. So those are a lot of the observability things that we've been working on this year, and so we're thrilled to share those with you. But I want to jump into that third category of helping you to plan and automate recovery, right? Because it's always best if you can automate recovery. That's going to be the fastest way to help your customers. A number of ways, a number of capabilities in AWS that you can leverage to make recovery easier. So first off, you can create CloudWatch alarms, and you can define recovery triggers based on some of the metrics that we've given you. Like earlier, we talked about the latency installed I/O. You can use those to set CloudWatch alarms, and then you can build Lambda functions to automate recovery based on those. Or if it's an EC2 issue, you can use EC2 auto recovery that can trigger based on CloudWatch alarms for instance status checks. So the great thing here is that the recovered instance is going to have the same, it's going to be identical to your original instance. So it's going to have the same instance ID and all the same instance metadata. Or you can use load balancers or auto scaling groups for auto scaling groups for your EC2 instances. So because auto scaling groups continues to maintain the same number of instances, when you see an unhealthy instance, it will automatically terminate that instance and create a new instance, and maintaining that same number. And so if your workload can handle recovery in a couple minutes, auto scaling groups may be for you. So this year, to make auto scaling groups a little easier, we actually the attached status checks into the instance status check API, as well as into the EC2 auto scaling groups. So with that, if you have that instance that is unhealthy because of your EC2 instances, it's not able to talk to our underlying EBS volumes, you can use that to trigger an auto scaling group recovery. And so it'll automatically replace that impacted instance, and it's going to ensure high availability and reliability of your application. And last but not least, for disaster recovery, you can copy snapshots across AZs. So First off, it's important to note, you want to be able to recover your data in the rare case of your volume fails. So EBS comes with a fully managed built-in backup solution with snapshots. So snapshots are a point-in-time copy of your volume, but it's stored in S3. So it has 11 nines of durability. So EBS snapshots are incremental and crash consistent. And so you can take crash consistent snapshots of all the volumes attached to your instance, or a subset of them if you like. So for disaster recovery, copying snapshots to another region or account is a really common use case. So to make that a little bit easier, last week actually, we launched a new functionality with EBS time-based snapshot copy. So with this, you can specify the desired duration of your snapshot copy, anywhere from 15 minutes to 48 hours. So these are going to help you meet any time-based concerns or limits that you need. And so you can ensure that you have predictability and consistency in your copy workflows. So if you're using it for disaster recovery, you can ensure your critical snapshots are copied in time in order to make your RPOs. Or you can use it to distribute fresh data on a timely basis for testing purposes, or provide developers with updated snapshot data on a regular and frequent basis. And so an important thing to note as well is that using time-based snapshot copy can actually help you reduce your overhead management if you're copying a ton of snapshots between either regions or accounts. And that's because time-based snapshot copies aren't constrained by those same concurrent snapshot limits that you have with standard snapshot copy. Additionally, for time-based copies, these don't impact the performance of your standard copy. So this is a complete different infrastructure. Time-based snapshot copy, super easy to enable if you're interested. So you can enable it via the console, API, CLI. So you can enable it. If you're enabling it in the console, it's pretty straightforward. You click the button that you want to enable it, and then you put in the desired duration. So it's pretty straightforward. And with that, I know Jody and I covered a lot here, and we touched on a lot of things. We are super thrilled to share a lot of the features that we'd been building over this year and kind of what our roadmap looked like in our mental model. But we wanted to also show you here are the different sessions that you can deep dive. And so with that, thank you guys for joining us. We touched on a lot of stuff. So if you guys have any questions, Jody and I are going to be here off on the side. We're happy to answer any questions that you might have. You also can reach out to us directly. So thank you so much for your time and for making the trek over here. We really, really appreciate it. Don't forget to take the session survey. We read that feedback all the time and work through that. So thank you guys so much for your time.